All righty, so what we're going to do is we're going to continue our working on, right? So we're going to be working with rational functions. And of course, when you see the word rational, you see ratio, and that means fraction, right? So we're going to have functions where we're going to have to either simplify the function, but we're also going to have to state what number or numbers should we exclude from the domain. So we did a few of these already. So if we have this, 60x to the third over 12x. Well, there we have a ratio. Now, we know that we can put any number we want in for x. There is a problem though. If I put 0 in for x, I'm going to get 0 in my denominator. And that's a problem, because when 0 is in your denominator, that expression is undefined. It means we can't do that, okay? So what we're really going to be on the lookout for today, fellas, is what values would make my denominator a problem, all right? So all you do, right? All you do is you take your function and you just take your denominator. If you have a variable in the denominator, you just take your denominator and set it equal to 0 and then solve that equation. And whatever that number is, right? Okay, whatever that number is, that tells you if x is this number, my denominator will be 0, and then that will be undefined. We can't have that. So in this problem, we know that x cannot equal 0. It can be any other number, but it can't be 0. So that's the first thing we want to do. But now let's simplify that. Well, this is just a division problem, right? 60 divided by 12 is 5. X to the third divided by x is x squared. Right? Does that make sense? That's not that big a deal. Right? Not that big a deal. Don't think either, right? All righty. So that was number 1. Now, number 2 is just like number 1. We got 70x squared over 100x. Well, once again, we have a variable in the denominator. So we got to be careful, because if we end up with a 0 in the denominator, that means it's going to be undefined. So we're going to take our denominator and set it equal to 0 and then solve that. And for the value of, for the value of x equals 0, when x is 0, our denominator is going to be 0, and that's undefined. So in this problem, x can be all real numbers except 0. Now, 70 over 100 times x squared over x, that's really what it is, right? So what do we got? We got 7x over 10, or 7/10x, right? Make sense?
Yes, sir.
All right, so let's make sure we know what we're talking about. When I say my function will be undefined at x equals 0, what that means is no matter what my picture looks like, doesn't matter what it looks like, my function can look like this. But if I tell you it's undefined at 0, I could have a hole, but I also could have an asymptote. You know, I could not have a hole, I might just have an asymptote. All right? That's what it means when we say x cannot be these values. Because if x was these values, I would either have a hole or I would have an asymptote. All right? Now, most of the time, you don't get, little equations that look like that. Most of the time, you get stuff that looks like this. And we did this one already, I'm pretty sure. We have polynomials. Now notice, once again, we have a variable in the denominator. So if we have a variable in the denominator, we have to make sure that we don't include values that would make the denominator equal to 0. Because if the denominator equals 0, you then have an undefined term, right? So I'm just going to take my denominator and set it equal to 0. Now we know that this is what type of equation?
Quadratic.
Yeah, this is simply a quadratic. So I'm just going to factor that. So the factors of a negative 21 that add up to positive 4. Well, I think that's plus 7 and minus 3. And then I would just let both of those factors equal 0. And I would solve both. So here's what I know. Whenever x is negative 7 or positive 3, my denominator is going to be equal to 0. So my values for the domain, what numbers can x be, will be all real numbers except negative 7 and positive 3. That's all. Now, we also want to simplify that. Well, I'm not going to do a lot more work than I have to. Simplify that just means what? Get the common factors and get rid of them. So I'm going to eliminate my denominator and rewrite it as x plus 7 times x minus 3. And fellas, you don't have to be a brain surgeon to figure out. If in the numerator it says x plus 7 and it's a math problem, x plus 7 is probably going to be in your denominator too, right? And then you just simply cancel common denominator, common factors, and I end up with 1 over x minus 3. Now pay attention. Make sure you find the excluded values before you actually simplify. Because if you simplify, you're going to include values that would still make your denominator undefined. Does that make sense? Make sure you do this first before you do this, right? Does that make sense? You got to do this first, right? All right. Next one's similar. X squared plus 6x plus 5 over n plus 1. All right, well, once again, we have a variable in the denominator. So we can't have a 0 in the denominator, so n plus 1 equals, set your denominator equal to 0, so n is negative 1. When n is negative 1, our denominator will be 0. Can't have that. So my domain is all the real numbers except, meant to say x, by the way. So x, not n, x cannot be negative 1. It can be any other number, but it can't be that. So now let's simplify. Let's simplify this expression. I don't have to factor the denominator, but I do have to factor. Now, it's a math problem, fellas. What do you think one of the factors of the numerator is? X plus 1, right? So, give me the factors of positive 5 that add up to positive 6. X plus 5, x plus 1. And what am I left with? X plus 5. Does that make sense? See now, if you actually simplified it first, there would be no numbers excluded from your domain. And then you would have a real big problem. Does that make sense?
Sure.
Yes or no? All right, so that's the first 4. All right, now number 5, they're going to change you up. They're going to give you a different method. They're going to give you a different method of factoring. 35x minus 35 over 25x minus 40. Well, I see a variable in my denominator, so I must make sure I don't include values that would give me a 0 in the denominator. So I just take my denominator and set it equal to 0. Now this time I'm going to factor, but it's not a quadratic. This is simply a GCF, right? What's the GCF of 25x and 40? Well, 25 and 40 would be what? Oh, my bad. I jumped ahead. My bad. My bad. I forgot I have to solve this first. My bad. So I get 25x equals 40. Divide both sides by 25. And I get x equals. Reduce 40 over 25.
8 over 5.
8/5. Good. So here's what I know. X cannot be 8/5 because if it was, my denominator would be undefined. All right? Makes sense? Yes or no? Now, let's simplify that. Well, we've learned when we solve this problem, what goes into both 25x and 40? 5, right? Yes?
Yes, sir.
Is that the GCF between 25x and 40?
Yes, sir.
5x minus 8. And now what are we going to do up top?
So,
Take out 35.
Is that good?
Yes, sir.
So what do we know?
Can you divide the 35 by the 5?
You can simplify this here. 7 times x minus 1 over 5x minus 8. Agreed?
Yes, sir.
All righty. All right, let's look at number 6. Number 6 says negative x squared plus 16x minus 63. All of that over x squared minus 2x minus 35. All righty. So what's our first problem?
that the denominator is 0.
We got to make sure we don't include values that will make my denominator 0. So x squared minus 2x minus 35 equals 0. This is easy. I'm going to factor that. Give me the factors of a negative 35 that add up to negative 2. Well, we know that that's negative 7 and positive 5. And then we just let each factor equal 0. Solve both of those. And we know that in this function, x cannot equal 7 or negative 5. Because if it did, our denominator would be what?
0.
And that would be undefined. And in a graph, that would look like either a hole or an asymptote. All right, now, so now we're going to simplify. Well, we already actually, we already factored this, right? So we got x minus 7 times x plus. Hey, fellas, what do you think might be in the numerator?
X minus 7.
I think either x minus 7 or x plus 5 might be in my numerator, right? Hey, what are you going to do first? What do I do there?
Let's change all the signs.
Yeah, I just factored out a negative 1, right? So this becomes x minus 16, and x plus, so everything, all right, now this is easy. Give me the factors of 63 that add up to negative 16. So I'm going to go x minus 9, x minus 7. Right? Agreed?
Yes, sir.
All right, and then cancel out common factors. So what do I got it simplified as? Well, I can go like this. I can distribute the negative 1. And that's this simplified. All right?
Yes,
Not
sir.
a big deal. Yes? Hello? Not a big deal. All righty. Number 7. Number 7 says, write the domain of each function in interval notation. All right, so we're going to talk about interval notation as well, right? We're still doing the same thing, but we're just going to write it so that we have a picture of our domain, right? So here's what our picture, f of x equals, right? 8x to the third minus 2x squared plus 12. All righty. I wonder if there's any numbers that I must eliminate from my domain.
So,
Anybody see something that would give me something that would be undefined?
negative.
Are there any numbers that I could not substitute for x? Hey, fellows, do you see a variable in a denominator?
No.
Do you see a variable under a radical?
No.
No, I don't see any. I don't see any values that I can't use in this picture. Does that make sense? All righty. So what does that look like? All real numbers. There's your domain, all the reals. What does that look like in interval notation? Well, if you took all the numbers on a number line, what's the number way out here? Negative infinity. What's the number way out here? Positive infinity. So interval, we know interval, it could either be a bracket if the number is included, or it would be a parentheses if the number isn't included. All righty. Well, we can't really include, oh, we can't really include infinity. Why? How come you can't include infinity?
It's not.
Because you never get to it. So that's what all real numbers looks like in interval notation. Does that make sense? Yes?
Yes, sir.
All right, so notice, fellas, there was 2 questions there. There are no numbers that you must exclude from the domain, right? Remember, we always look for variables in denominators or variables under radicals, okay? All right, so now that's number 7. Number 8, we do have a little bit of work to do here, ready? It says f of x equals radical 2x plus 1. All righty. Now I say to you, write the domain in interval notation. However, we have to be careful with this domain because where is my variable? It's under a radical. All righty. So now, what can't you have under a radical?
Negative.
A negative number. all right? If you have a negative number under a radical, we actually had to invent what they call imaginary numbers, right? So what we're going to do here to find out what values we're going to exclude, we're going to take the expression under the radical and make sure that it is not negative. And what does not negative mean in math? Greater than or equal to 0. And then you solve that. 2x must be greater than or equal to -1. So x must be greater than or equal to a -1/2. Now, what that means now, if I'm going to write my values, all right, so like if I give you a number line and I said to you, right, tell me the numbers that x can be. Well, here's what we know. Here's -1. So here's -1/2. What I know is x can be equal to a -1/2 or greater than a -1/2. But what I do know is there are no numbers over here that x can be. So it's included. My furthest left number is included, so I get a bracket, -1/2. And where does it go? All the way to?
Infinity.
And that, of course, you can't include because you never get there. So that's your domain in interval notation. All right? Does that make sense? Yes or no? And I would read this as x, all right, is greater than or equal to, because I'm greater, right, -1/2. All the way to infinity. But I wouldn't say all the way to infinity. Right? Does that make sense? Notice, once again, we had to be careful of our domain because we had a variable under the radical. Comprende? Yep. No, maybe?
Sir.
All righty. Now we're simply going to, the next 4 questions, are simply write the equation of a line that satisfies the following. All right, so write the equation of a line, right? Anytime you have to write the equation of a line, you need 2 things. You need the slope and you need the y-intercept. If you have those 2 things, the slope is m, the y-intercept is b, y equals mx plus b. That's why they call that slope-intercept form, right? So as long as you know that anytime you see the term, write the equation of a line, that just means find the slope and the y-intercept so you can do it. All righty. Well, number 9 tells you the slope is -1, and it says the line actually passes through point 4, -2. I think we did this one the other day, right? So I know that I'm trying to write this equation. So I know I need to find out what m is, and I need to find out what b is. Now, they told me, they were nice. They told me what m was. But they didn't tell me what b was. But they gave me enough info to figure it out. What's this? Yeah, when they give you a point, fellas, they're telling you what x and y are, right? So I can just substitute the numbers I know and solve for b, right? So -2 equals -1 times x. Oh, but x is what? 4 plus b. So -2 equals -4 plus b. So b equals 2. So I know the slope is -1. That's m. I know the y-intercept is 2. That's b. So y equals -1, we don't really write -1, plus 2. All right? That's not that big a deal. All right? And I'm pretty sure we did the next one too, right? Y equals mx plus b. I have to write my equation in this form. It has a slope, right, of -1/7, and it passes through point -2, 4, right? So I know what m is. I don't know what b is, but I do have enough information to figure it out. So I'm just going to substitute what I know. So I'm going to put 4 here equals m is -1/7 times 2 times x -2 plus b. And now I just simplify. 4 equals, well, -1/7 times 2/7 is times -2 is 2/7 plus b. Get b by itself. Well, 4 with 7 as a denominator is 28/7. Minus 2 is 26/7. All righty. So now I have what I need. I have my slope and my y-intercept. So my slope is -1/7 x, and my y-intercept 26/7. Not that big a deal, right?
No, sir.
This is algebra 1, by the way. All righty. Now, the next two problems, they don't give you the slope. They just tell you 2 points that the line passes through. So what must you do? Well, you still need what? Write the equation of a line. Guess what you still need? You still need the slope and the y-intercept, all right? Well, now you just use your slope formula. Change in y over the change in x, which means y2 minus y1 over x2 minus x1. No big deal. So I'm just going to do this. I'm going to make this number 1. I'm going to make this number 2, right? So I'm going to go y2, -1 minus 2 over 0 minus -3. So I'm going to get what? -3 over 3 is -1. That's all. Now I got to find what? The y-intercept. Now I can use either of those 2 points. I can use either of those 2 points, fellas. All right? I'll just write my equation. Y equals mx plus b. All right, I already know m, so now I'm trying to find b. All right, and they give me 2 points I can use. I'm going to use this one over here because I'm pretty sure that if I put a 0 in somewhere, it's going to make things really easy. So y is -1 equals the slope m, -1 times 0 plus b. So I get -1 equals b. All right, there you go. So now you have your 2 pieces of information. Your slope is -1. Your y-intercept is -1. So what do you get? Y equals -x minus 1. That's not that hard, right? Not that hard, right?
Yes, sir.
All righty. Last one of these, right? You got a line that goes through 0, 4, and -1, -1. If I ask you to tell me the equation of that line, I know I need the slope and I need the y-intercept. All right, let me find the slope for you. So my slope is going to be 4 minus -1 over 0 minus negative 1. So that's going to be 5 over 1. So my slope is 5. Well, now I'm just going to take the numbers I know and put them in here and figure out what b is. So I'm going to use this point right here. So y is 4 equals m is 5 times 0 plus b. So 4 equals b. All righty. So now you have your 2 data points that you need. Y equals mx plus b. So y equals 5x plus 4. All right. Now, fellas, none of that is really difficult. None of that is really difficult, right? So now I'm going to give you one that's relatively difficult, right? I want you to write the equation of the line. So what did I just say? The equation of a line. So what do you need?
Y equals mx plus b.
You need the slope and the y. I want you to write the equation of a line that is tangent to f of x equals 3x squared at x equals negative 1. Because this function right here, fellas, that is not a line. So all the other problems you had, everything was constant. So let's make sure we know what we're talking about here. It says, write the equation of a line that's tangent to this function at negative 1. So let's make sure we know what this function is. Fellas, that's a quadratic, right? That's going to be, right? That's going to be what? If I told you x was 0, put x in here. What do you get? 3x squared, right? X is 0, right? X, 3x squared, y. Well, if you put a 0 in there, what's 0 squared? 0 times 3? 0. Put 1 in there. X is 1. What's y?
3.
3. So 1, 3. All righty. Put negative 1 in there. What do you get?
3.
Yep. You should have known that this is what the parabola looked like, right? All right, now pay attention. So this is what your parabola, oh, my bad. I don't know what I just did. This is what your parabola looks like. It's really steep, right? Now, the question says, write the equation of a line that's tangent to this picture at x is negative 1. Well, we know what we mean by that, right? So we mean tangent So I know what about this picture, fellas? I still need to write the equation of this line. What do you know about the slope, fellas?
That it's negative.
It's negative. Ooh! Very good. How do you find the slope of that line?
Find 2 points on the line.
isn't a derivative the instantaneous slope? Fellas, function of x equals 3x squared. What's f prime of x? What's the derivative of that?
XX.
Beautiful. So now, take -1 and stick it in there. What do you get?
Negative.
Negative. Beautiful. So my slope of this tangent line is -6. All righty. What do I got to do in order to, I only have one of the two pieces of information I have. I still need a what? A y-intercept. Anybody want to tell me how I'd find the y-intercept? What's this?
Slope.
Well, I need a point on that line, right? What's the coordinates of that point?
Oh, -1, 3.
Thank you. See how easy that was? So now y equals mx plus b, right? I have m, I just don't have b yet, right? So I'm going to go y is 3 equals -6 times -1 plus b. 3 equals 6 plus b. b equals -3. All righty. Now, if I continue this picture down, it seems to pass and hit the y-intercept at -3, right? So I got a slope of -6. I got a y-intercept of -3. Y equals -6x minus 3. That is the equation of that tangent line. All righty? Does that make sense?
Yes, sir.
Now notice, that's a lot more work than what you had to do with the other ones. But notice you still had to do what? Find the slope and the y-intercept. You also had to know what the word tangent meant, right? And then you had to figure it out a little bit, fellas. You had to know what this function gives you, right? This is the problem with math if you don't stay on top of it from the get-go, right? Does that make sense? Now, so the last thing you have to do this year, right? The last thing you're going to have to do this year is the one problem on this test, on this assignment that we haven't done, right? And it's just like the one we just did, only it says, write the equation of the line that's tangent to this graph. So, in your head, you should have an idea of what this graph looks like. All right? And then what you're going to do is you need to figure out what the equation of the line that's tangent to the graph when x is 0. All right? Now, e to the 0, anything to the 0 is what?
1.
1. And you should know, right, what? So this looks something like this, right? Yes? Hello? Did you guys know that?
Why?
That's 0, right? So
Yes, sir.
that's what? 1, right?
Mhm.
Yeah, if you go to 1, right? If you go x is 1, right? That more looks more like 2. If you go to x is 1, right? 3 times 1 is 3. E to the third is, a big number, right? What's E? What's E about? So this would be a hell of a lot more steep than this, right? This would be much more like this, right? It would be super steep, right? Right, so really what you're doing is you're trying to figure out the slope of this line. You already know the y-intercept, don't you? Don't you?
Yes, sir.
Yeah, you do, if you're paying attention. All right, so that's your only homework problem. Does that make sense?
You just want to find the tangent of that line.
Yes, sir.
Excuse me?
That's what you want to do for